Hi guys, it's Miss Smith here. Just wanted a quick video reminder about the distributive property. In case you didn't get to write down the definition in class, I have put it here for you. So the distributive property is a property that we use to multiply a sum by multiplying each addend separately and then adding the products. I put some of the key vocab in different colors here. So remember, sum means addition. Addend is the two numbers that you are going to add together to create the sum. And then product, remember, has to do with multiplying. So what this summary or this definition is saying is I need to find two numbers that will add together to make a sum, and I'm going to be multiplying it by something to find an easier way to make the products. So we will come back to that definition at the end of our lesson here. So as I teach this lesson, remember I like to use metaphors to explain what's going on in the math world. So metaphor 1, the distributive property is like one person showing up at a party and there are two people already at the party. So if you think of the situation, the new person that's going to show up is going to have to say hello to both of the people who are at the party. Maybe I'll give him a little hello. So the new person that's going to come is going to say hello and hello to each of the people that are there. These two people do not say hello to each other because they are already there at the party, and that would be very awkward to greet someone in the middle of a party when you've been talking with them for, quite a long time. So similarly, we can expand this onto the same metaphor that if two people are showing up to a party and there are three people already there, each of the people are going to have to say hello to each person at the party. So this is person 1 saying hello to all three of the people that they have not yet said hello to. And person 2, I'll do in another color here, is going to also have to say hello to each of the people once they arrive. And again, these two people are not going to say hello to each other because they've already been hanging out and are showing up together, and these three people are not going to say hello to each other as well because, again, they've already been hanging out, and socially that would be very awkward. So think of that scenario as you are working through some of these problems. So let's look at the first problem. This is like that A and B are hanging out together. This is that addend that we were talking about. A is an addend and B is an addend, and it helps that there's the addition sign there. But 2 will need to come in and say hello to A, just like 2 will have to say hello to B. And remember, A and B are not talking to each other because they're already hanging out inside the parentheses. So when 2 and A hang out together, they will just make a 2A. There's nothing more that they can do until we know what the A represents. And then same with the 2, when the 2 hangs out with the B, I get a 2B. And remember, these guys are still adding together. Okay, so this is one where it's almost a little bit nicer. I don't have the math to do, but it's a little bit tougher because we have the coefficients that we have to worry about and making sure that we don't try to oversimplify and put numbers together too much. So let's look at it without variables and see what it would actually look like to see if it would actually be a method that might make doing multiplication or addition a little bit smoother. So I'm going to have this 5 hang out with the 1, and the 5 also has to hang out with the 6. So when the 5 and the 1 hang out together, they are going to make a 5 because, again, this is multiplying. These numbers that are coming in are multiplying. And then the 5 is going to multiply by a 6 to make a 30, and then that leaves me with my addition problem of 5 plus 30 equals 35. All right, let's look at a second example. And this one, it doesn't look like it's a distributive property. It's 7 multiplying by 23, but we have this property because these two are actually equivalent. So I should have 7 trying to multiply by a 20 and 7 trying to multiply by a 3. So I'm going to draw my arrows just like I did for the people to remind myself who is hanging out with whom. So when 7 and 20 hang out, it's the same as 7 times 2 with a 0 on the end. So if I know my math facts of 7 times 2 should be 14, use my 0 as 140, then I'm going to look at my 7 times 3, and I have a 21, and now I'm just left to add these two numbers up, and I have a 161. So it's taking a problem that looks a little more complicated and breaking it down into 2 steps with basic math facts to fill in. So this one would be a double, like the 2 people showing up at the party, and then the 2 people showing, 2 people already being there. So in this case, 10 and 2 are making the 12, and 30 plus 4 is making the 34. So I'm gonna do my 2 color codings. 10 and 30 will have to hang out. They will first make a 300. 10 and 4 will then hang out, making a 40, but we're only part of the way done because only the 10 has greeted the 2 people that are already there. The 2 has to do the same, but luckily multiplying by 2 is pretty easy math. So 2 times 30 is 60, and then 2 times 4 is 8. I can already tell this 40 and the 60 are going to make a nice 100. So as I add these, a problem that might have been done doing a stacking method or a lattice method now looks a little bit more simple, and I have 408. Okay, so remember, you can do it with variables, you can do it with many people showing up at the party or being already at the party, and if it's a math party, you know it is already awesome. But just to remind you here too, the distributive property here is that we're multiplying a sum, so that's the number in the parentheses, by multiplying each addend on its own, the 2 items inside the parentheses separately, and then adding up the products. So if you have any questions, leave some comments in the spots down in the comment section below. Thanks, have a good one.